CuSO4. So here I have CuSO4, then I have water, and then I have copper. If you split it, it will get Cu plus 2 and SO4 2 minus. This is a water and this is a copper. So if you go and if you see one by one, so see at anode. First we will see at anode. At anode first we will see water. Okay? Or first we will see SO4 2 minus. Yes or no? So at anode we will see SO4 2 minus. Last class also I told you that S here is in +6 state. So here the oxidation of SO4 2 minus is not possible because sulfur in SO4 2 minus is in this maximum oxidation state. So further loss of electron is not possible here. Then we will see here water. So you know water oxidation reaction, it will be loss of electron, O2 and H plus. If you balance the reaction, that is 4, 4. And for this, if you write down the SRP value is 1.23 volt. You have to remember this. 1.23 volt. Here one more possibility is there of copper. So copper also can undergo oxidation here because you are using here copper electrode. Now you know this copper electrode is an active metal electrode. I have done in the previous section. Active metal electrode. If you see the type of the electrode, you don't know. Active metal electrode, inert electrode, gaseous electrode. So here copper is active metal electrode, means in last problem we have taken the graphite electrode or platinum electrode. All electrode were coming under inert electrode, means they just provide the surface of oxidation or reduction. But here electrode itself will undergo oxidation or reduction because they are coming under the active metal electrode. So I have to consider here copper also. So copper also can come at anode and it can act as an anode and form Cu plus 2 electron. And for this, the SRP value of copper is 0.34 volt. Clear? Now you know lesser value anode and more large value cathode. So which is the less value? You can see here which is the less value. The less value is here copper. So this will do the reaction. This reaction will not form. Clear? So here copper will undergo the reaction whereas water will not undergo the reaction. Next, at cathode. Now which are the chances for cathode? First Cu plus 2 will come. So Cu plus 2 electron will give what? Cu. Clear? And for this SRP, if you write down, it will be remaining same. That is 0.34 volt. Clear? Then at cathode who can come? Again at H2O can come. Yes or no? This can go at anode. Because this is a metal and metal can lose the electron. One who can lose the electron, oxidation, and oxidation occurs at anode. So this will go at anode. Now on cathode there are two chances. Whose chances? First chances of Cu plus 2 and another chances of water. So one Cu plus 2, their SRP value is 0.34 volt and water. Now at cathode water will undergo reduction. So we have to write down the reduction reaction of water. That is plus electron here, hydrogen gas will be liberated and OH minus. So here 2, here 2 and the charges will be 2. And for this you have to write down the SRP value as minus 0.83 volt. Minus 0.83 volt. Clear? Now you know less anode, more cathode. Which is the more value here? This copper is having the more value. So this reaction will occur, this reaction will not occur. So if I write down here net reaction, so net reaction I can write down is, see here, at anode which reaction will occur? At anode this reaction will occur, that is Cu solid gives Cu plus 2 electron. And at cathode which reaction will occur? At cathode reaction will occur is Cu plus 2 electron gives Cu solid. Now these 2 electron get cut, this Cu also get cut. So shall I cut this value also? No, Cu plus 2 will convert into Cu plus 2. This value will not be cut because these are the ions and the ions have a different molarity, and ions have a different molarity means this value will not be cut. Okay, so in short, electrolysis of aqueous CuSO4 using copper electrode at anode Cu plus 2 will be formed, and at cathode Cu will be formed. So see what happens actually at anode. See, actually there are one electrolytic cell. Here I have filled CuSO4. This is anode, this is cathode, so this is anode, and anode itself is a what? Copper. So this will be copper electrode and cathode. So see here, this anode, this Cu is converting into what? Cu plus 2. So slowly this portion is going, because this Cu is converting into what? Cu plus 2, Cu plus 2, Cu plus 2. And here this Cu plus 2 is converting into what? Cu at cathode. Final product is obtaining is what? Cu. So here copper is getting deposited. In short, this reaction is a purification of copper reaction. You will understand in general principle. So this reaction is a purification process, purification of copper. So if question comes that electrolysis of aqueous CuSO4 using copper electrode, so you have to say that at anode Cu plus 2 is formed and at cathode Cu is formed. Means at anode, actually anode itself is a copper. So slowly this anode copper is getting eaten up in the reaction. After certain reaction, you will see that weight of anode will be reduced and weight of cathode will be increased. For example, before starting the reaction, if I have taken the anode of copper of 1 kg and cathode also have taken 1 kg, after the reaction I will see that anode weight will be reduced and cathode weight will be increased. Means anode weight is reduced, means here anode is eaten up. We have seen in this copper here. Okay, so anode is eaten up and cathode weight is increasing. Means here what happens, that the anode copper, from this copper, pure copper is depositing on cathode, and here after finally something will find some here mud like a substance which is known as a anode mud. This I will explain detail in general principle. Okay, so this reaction, electrolysis of an aqueous CuSO4 using copper electrode, is a reaction actually of purifying the copper. Please remember this. So at anode you will obtain Cu plus 2 and at cathode you will obtain Cu, and Cu plus 2 will be in the solution. So completely Cu plus 2 will be taken up by the cathode, and slowly cathode weight increases and completely anode will be eaten up, and finally you will see some impurities are settled down at the bottom of the anode, and that anode itself is known as a what? Anode mud. So this reaction is nothing but a purification of copper. This I will also explain in detail in next chapter. Okay, so take this screenshot just to remember this anodic reaction and cathodic reaction. Please see here, copper will get cut, 2 electron will get cut, but here Cu plus 2 will not be getting cut because they both the concentration are different. So here Cu plus 2 concentration will be x molar, so here Cu plus 2 will be nearly y molar, here 0.1 molar or 0.2 molar. That's why I'm here Cu plus 2 and Cu plus 2 I am not cutting it. Please remember this. Most of the students, they make a mistake. What they do, they simply cut Cu also, they cut 2 electron also, and they cut Cu plus 2 also. So what remains? Nothing. So it's not possible. Cu plus 2, this Cu plus 2 cannot be cancelled out because both the Cu plus 2 ions have a different concentration. Hence it cannot be cancelled out. Clear? Okay. So I hope you have taken this screenshot. Next portion in this, I will go for 7th topic, that is the electrolysis of Na2SO4. Clear? So you can write down the topic. See, you can do electrolysis of any salt solution. Just to remember the SRP value. Check it out through the SRP value. You can directly determine who will come at anode, who will come at cathode. Now we have done many topics. This is the last topic I am doing. So in exam they can give you NiCl2 also, Na2SO4 also, CuSO4 also, PbSO4 also. Just you remember the SRP values, certain of metal, and this SRP value should be mug up. You have to remember this SRP value, and by comparing the SRP value we can easily determine who can come at anode and who can come at cathode. Clear? So now next topic we write down, that is electrolysis of aqueous Na2SO4. Okay, This is important. Now here we have Na2SO4 and this is in an aqueous state, means water will also come. So I will separate it, that is Na plus SO4 2 minus, and plus I also have here water. So at anode oxidation occurs. So at anode first I can take as SO4 2 minus, again here SO4 2 minus S is having plus 6 oxidation state, which is its maximum oxidation state. So further loss of electron is not possible, hence here oxidation of SO4 2 minus is not possible, whereas I have here water. So I will write down the oxidation reaction of water. So water means I will obtain here O2, I will obtain here H plus, and I will obtain here E electron. If I do this 4 4 means here when SO4 2 minus anodic reaction is not possible, then who will undergo oxidation reaction? Water will undergo the oxidation reaction. So at anode water will undergo oxidation in electrolysis of aqueous Na2SO4. Clear? Because sulfite cannot undergo oxidation because it cannot lose the electron. Why it can lose the electron? If you see the oxidation state of sulfur, which is plus 6, and plus 6 sulfur oxidation state is maximum oxidation state. Beyond that it cannot lose the electron. When it cannot lose the electron, it cannot undergo oxidation, means this reaction will not occur at anode. So instead of SO4 2 minus, who will come? Water. So water will undergo oxidation, means water will do the reaction at anode in aqueous Na2SO4. Clear this part? Now we will see at cathode. So at cathode the race is between first Na plus. So Na plus plus electron, if you see this you will get Na solid, and their SRP value if you see this if you see the SRP value is minus 2.7 volt. SRP value is minus 2.71 volt. And similarly water will also can come at cathode. So electron here, and it will form here H2 plus OH minus, here 2 and 2 4, here 2. So their SRP value is, you can take the SRP value as minus 0.83. Now you know one who is less anode and one who is more cathode. Who is more here? So you can see here, see lesser value anode, I have given you shortcut, less anode, anode oxidation, loss of electron, liberation of gases except hydrogen. More value cathode, reduction, metal deposition, and or liberation of hydrogen gas. So more value will act as a cathode. So who is having the value more? Here the value of more is this value. So this reaction will not occur. Clear? So at anode, if you see at anode, which reaction will occur? At anode reaction will occur is of water, that is 2H2O gives 4H plus O2 plus 4 electron, and at cathode which reaction will occur? Water itself, H2O plus 2 electron gives what? H2 plus 2OH minus. If I multiply here, this will be 2. If I multiply this by 2, yes or no? Because you have 4 electron, to make 2 here, 4 electron have to multiply by 2 here. So here 2H2O instead of 2 it will come here 4. This will be also 4, 2H2O and 4OH minus. 4 electron get cut. 2H2O plus 4H2O will be 6H2O gives what? 4H plus O2 plus 2H2 plus 4OH minus. Clear? Here 4H plus and 4OH minus. So I can write down here 4H plus and 4OH minus means 4H2O. I will get here O2 plus 2H2O. Here 4H2 and here 2H2O is remaining. So 2H2O gives what? O2 plus H2. Clear? This will come at O2 gas is liberated at anode, and this will come at cathode. Clear? So electrolysis of aqueous Na2SO4. In this, if I say that which are the product obtained at the anode, so at anode oxygen gas will be liberated, and at cathode hydrogen gas will be liberated. So in short, I can say one short point that electrolysis of aqueous Na2SO4 is actually electrolysis of what? See here, in aqueous Na2SO4 electrolysis, SO4 2 minus and Na plus are not doing reaction itself. Who is doing reaction? Water is only undergoing oxidation and water is only undergoing reduction. So final conclusion, we can say that finally electrolysis of aqueous Na2SO4 is actually electrolysis of water only. Please remember this. This can come in the MCQ, electrolysis of water. See here students, what I mean to tell you is, you can see here by comparing this anode SRP value, we came to know that at anode water will only undergo oxidation instead of SO4 2-, and at cathode water will only undergo reduction instead of Na+, and at anode oxygen will be liberated, and at cathode hydrogen gas will be liberated. But I have taken the substance what? Na2SO4. But Na2SO4 is not undergoing any kind of an oxidation or reduction reaction. So finally conclusion I can tell that electrolysis of aqueous Na2SO4 is an actually electrolysis of what? Water only. Na2SO4 does not play any kind of a role. Clear? So remember this point. They can ask you in a 1 mark question or 2 mark question that electrolysis of aqueous Na2SO4 is an actually electrolysis of what? It's an actually electrolysis of water only, because at anode and at cathode instead of SO4 2- and Na+, who are doing the reaction? Water is only doing the reaction. So what final product will obtain? At anode will obtain oxygen gas, and at cathode hydrogen gas will be obtained. Please remember this. Okay, they can ask you in the exam also. What the question can come? The question can come, what are the product obtained at the anode and cathode during the electrolysis of aqueous Na2SO4? Most of the student does what, you know? They do like this, Na2SO4, they will do Na+, they will do SO4 2-, then they will do at anode they will do, here they will do water. Okay, they will say here oxygen gas is liberated and here sodium is liberated. No, these are not the answers. No, it is not possible. Aqueous electrolysis of aqueous Na2SO4 is an actually electrolysis of water only. At anode oxygen gas is liberated, and at cathode hydrogen gas is liberated. Please remember. So here I am ending the topic as per the book point of view, but in exam they can ask electrolysis of any point in any salt. They can ask. You have to remember, please remember this SRP value. You have to mug it up. I know it's a bit difficult to mug up, but you have to do it here. Okay, certain things to be remembered means you have to remember. Then 2-3 problems, or one more question you can write down here. Very simple question. Factors you can write down. Factors for product obtained at electrode during electrolysis. So what can be the factor? So see, it's very simple. You have to remember, first factor is their SRP values. Yes or no? The product obtained at the during electrolysis. Okay. So first factor is what? SRP. Yes or no? On what basis we are deciding that which product will come at anode and which product will come on cathode? We are deciding based on this SRP value. Okay. So first factor is SRP value. Second factor is concentration. Yes or no? Second factor is concentration. Third factor, see here. See, in the previous question, I have taken platinum electrode. Somewhere I have taken the graphite electrode. So that platinum and graphite electrode are nothing but an inert electrode. So they will not undergo oxidation and reduction. Just they will provide a space to do that oxidation and reduction. But you see here, in this today's class, I have taken the aqueous solution of CuSO4 using copper electrode, and we have seen that copper electrode is also undergoing the oxidation. So it can also depend upon the nature of electrode, which kind of electrode we are taking. Yes or no? Whether we are taking gaseous electrode, or we are taking the active metal electrode, or we are taking the inert electrode. So it is depend on the SRP, it is also depend upon the concentration and nature of it. These three things are remember enough. Certain things are given in the book which are too much, maximum, need not to worry about, just remember these three things. On what factors does the product obtain the electrode during electrolysis? The main thing is SRP. You have to see whose SRP is more or less in anode or cathode. Yes or no? Anode means less SRP will come. Cathode means more SRP will come. Okay. So this depend upon SRP. In certain book they have given SOP also, but I told you we will do each and every problem by taking SRP only. If in the question they are giving the SOP value, please you convert into SRP value and you know the relation. Okay. So depend on the SRP value, that is standard reduction potential value, or you can say potential of the cell also. Clear? We will see the concentration, whether highly concentrated or less concentrated. It is also depend on the concentration and nature of electrode. Nature of electrode means which kind of electrode we are taking. Whether we are taking active metal electrode or we are taking that inert electrode. You know, inert electrode does not come into the picture because they just provide a space to do the oxidation reduction. But if it is a active metal electrode, that active metal electrode will come in the picture because they also undergo oxidation and reduction reaction. So I hope you are remembering this. Clear? See, sometime I am speaking very fast. If I am speaking very fast, please you comment me so that I can improve myself. Clear? So factors for the product obtained in the electrode during electrolysis. This is the question which can come certain. It's very easy question. It can come certain for 1 marks or 2 marks. So now next we will move towards, we will solve 2-3 example based on this. Question, how many amperes means you have to find current. First I will read the question. Okay. First you copy out by making the post button or screenshot. So how many amperes of electric current means I have to find I should be passed when aqueous solution of Na2SO4 is electrolyzed between graphite electrode at 300 Kelvin, temperature is given, and electrolysis is given is aqueous solution of Na2SO4. And just now we have done in this topic that electrolysis of an aqueous Na2SO4 is nothing but what? Electrolysis of water itself. Graphite electrode at 300 Kelvin show that 250 ml per minute of O2 gas. So they have not given a hydrogen gas, they have given O2 gas, and O2 was obtaining at anode. So we have to consider the reaction for anode. I will explain this, okay? And 1 bar pressure. Clear? So we will see this. Now see here, students. First I will do the summary part. They are telling the aqueous Na2SO4, this electrolyte they have given, and they are doing the electrolysis of this portion. Yes or no? But we know that electrolysis of an aqueous Na2SO4 is an actually electrolysis of what? Water only. It is an actual electrolysis of water. So water is only coming at anode. Yes or no? This H2O is only coming at anode, and this H2O only is coming as cathode. Yes or no? Just before this question only I have done this. Aqueous solution of Na2SO4 is given. We know that electrolysis of an aqueous Na2SO4 actually is an electrolysis of what? Water. Means water is only coming at anode and water is only coming at cathode. Now in question they have given the comparison of oxygen, means they are telling, and at anode oxygen is depositing and at cathode hydrogen is coming, and in question they have given oxygen gas. They have not given hydrogen gas. They have given oxygen gas. Means the question itself is telling solve the problem by taking the anodic reaction of water. Question itself is saying what? Solve the problem by taking anodic reaction of water. Please remember this part. If instead of O2 gas, here if it was hydrogen gas, then what you have to do? We have to take the cathodic reaction of water and to solve the problem. But instead of O2, instead of H2, they have given O2. O2 gas is coming at anode. So question itself says solve the problem by taking anodic reaction of water. Clear? Now I hope you understood. Clear? Now see here, we'll solve the problem. How many ampere, means I we have to find it, of electric current should be passed when aqueous solution of Na2SO4, aqueous Na2SO4 at 300 Kelvin. So that 250 ml volume is given, volume of O2 is given. How much? 250 ml per minute. Per minute means time is given 1 minute, that is 60 seconds. Clear? Because time is taken in seconds under 1 bar pressure. Clear? So now how to find this? See, first what we will do, you can see here P, V, R, you know 0.08314. We will solve. First we will solve number of moles. Okay. So how many number of moles are there in 250 ml? So we know that PV equal to nRT. If I take here V of O2, so N of O2 will come here. So pressure is given 1 bar, volume of O2 is given 250 ml by 1000, because here when R I am taking in liter, because R is nothing but what? The R value 0.08314 which I am taking, this R value 0.08314 I am taking in liter, means I have to take this volume also in liter. So I will take here, instead of 250 I will take here 250 by 1000 equal to N moles of O2. R means 0.08314. Yes or no? And I told you, whenever you are solving the problem, please solve the problem by taking of electrochemistry. R is 0.08314. Temperature is in Kelvin, that is 300. So I will obtain the mole of O2. So how will I obtain the mole of O2? Means I will do the division and multiplication here. See here, 0 0, 25 ones are 25 fours are. So n of O2 I will obtain here is, here I will do 1 by 4. So 1 divided by 4 I will obtain here 0.25 equal to n of O2. Multiply by here I will do 0.08314 into 300, 24.942. So mole of O2 I will obtain here is 0.25 divided by 24.942. 0.01 mole. The mole of O2 obtained here is, that is 0.01 mole. Now I told you, clear? So 0.01 mole I obtained. Now here O2 is given and they have given here aqueous Na2SO4. So I told you have to write down the anodic reaction of water, because at anode only oxygen is coming. Comparison of oxygen is given. That's why I am writing for at O2. Before that going, can I find IT by 96500? No. See here, first I will write down the reaction of water at anode. So H2O gives here O2 plus electron and plus here H plus. So here 2, here 4 and here 4. See here. Now they have given oxygen, yes or no? So we know that when 4 Faraday is passed, this is a balanced reaction. Now you have to compare. This problem we have done previous also. So when 4 Faraday is passed, I am getting 1 mole of O2. Yes or no? When 4 Faraday is passed, I got 1 mole of O2. Actually, how many mole of O2 I have? I have 0.01 mole. So how much Faraday will come? So Faraday will come here is 0.01 into 4, that is 0.04 Faraday. Now you know what is the formula for Faraday? This also I told you, no? IT by 96500. Yes or no? Because see here students, I told you last class also, Faraday means what? If I have Q equal to IT, this IT will give me Coulomb. And if I divide by 96500, I will get a Faraday. So Faraday is nothing but what? IT by 96500. So Faraday I got is 0.04 and here F means IT by 96500, or I can write down here IT by 96500 equal to 0.04. I need to find current I. Time I have, how much I have? Time I have 60 seconds by 96500 equal to 0.04. So current I will obtain is 96500 into 0.04 divided by 60. I will get 64.3 ampere. I get the answer of I as a 64.3 ampere. Clear? So this is your answer. See what I have done. First I have determined the number of moles of O2. Sir, why O2? Because they have given here O2. If instead of hydrogen they have given, I would have find the volume of hydrogen. Okay. So this volume of hydrogen if would have given, I would have obtained moles of hydrogen and I would have written cathodic reaction of water. But here instead of hydrogen they have given the oxygen, and at oxygen will come at anode only. So I have written here water anodic reaction. So what I have done, first I have determined the moles of O2, actually how much are used in this reaction. Then I have written as O2 is given, so I have written the anodic reaction of water, because you know at anode when I do the electrolysis of water, oxygen will come. When I balance the reaction, I got to know that I will get 4 Faraday at 1 mole. Actually how many moles are used? 0.01 moles. So how much Faraday? 0.04. Now you know Faraday value. Faraday value is what? IT by 96500. In that T is given. 96500 is constant current. We need it. So we got 64.33 ampere. In this way we have to solve the problem. So I hope we have understood. I have covered here most of the topics. Okay. After last, see here I am solving now I am solving 2-3 problems only. But as and when chapter will get complete, I will make a one complete lecture based on problem, very good problems, on complicated problem. At present, this is only there. Okay, you can copy out. If you have any doubt, please write down in the comment section, and you can tell me freely. If I commit any mistake, you can ask me freely, you can tell me freely. Okay, so I hope you are understanding. Thank you.